August 15th, 1977. A radio telescope in Ohio is scanning deep space, the same routine scan it runs every night. For 72 seconds, something comes through that has never happened before, and has never happened since. It's 30 times stronger than anything the telescope should be picking up. It comes from one exact point in the sky, and then it's just gone. 3 days later, an astronomer reviewing the printout circles that exact moment and writes a single word next to it. Wow! That printout still exists today. Nobody has ever explained what those 72 seconds actually were. The telescope was called Big Ear, a large fixed radio observatory operated by Ohio State University, built specifically to scan the sky for unusual radio signals as part of a long-running search for signs of extraterrestrial intelligence. Big Ear didn't move to track objects the way most telescopes do. It had no motors to pan or tilt. Instead, it relied entirely on the rotation of the Earth itself to sweep its field of view slowly across a narrow strip of sky, recording whatever passed through, night after night, mostly picking up background static and known cosmic noise. Because the telescope was fixed in place, any real signal from a specific point in the sky would rise into its field of view, peak in strength as it passed directly overhead, and then fade out again as Earth's rotation carried it out of range. A process that, given the width of Big Ear's field of view, would take roughly a minute or so from start to finish. The data was printed out on continuous sheets of paper, rows and columns of numbers and letters representing signal strength at each moment, meant to be reviewed later, by hand, since the volume of data collected each night was far too large to monitor in real time. The astronomer reviewing that printout was Jerry Ammon, a volunteer working with the project. Scanning through pages of largely unremarkable data, he came across a sequence unlike anything he'd seen in the entire program's history. Radio astronomers typically measure background noise on a low numerical scale, and a strong signal might register a few points above that baseline. This particular sequence read 6EQUJ5. A shorthand code representing a signal that spiked dramatically, held remarkably steady, then faded away, matching almost exactly the pattern you'd expect if a real, narrowband signal briefly passed through the telescope's field of view exactly the way Earth's rotation would carry it. The shape of that rise and fall mattered just as much as the raw strength of the signal, since it closely resembled the expected profile of a genuine astronomical source moving through a fixed telescope's view, rather than the kind of irregular spike typically associated with equipment interference or a passing terrestrial radio source. Ammon circled the sequence in red pen and wrote "Wow" in the margin, a reaction that gave the signal its lasting name. Here's what made the signal specifically strange. Beyond its raw strength, it appeared at a very particular radio frequency, close to 1,420 megahertz, a frequency associated with neutral hydrogen, the most abundant element in the universe. Scientists searching for potential extraterrestrial signals have long treated this specific frequency as a logical one to watch, reasoning that any civilization attempting to signal across interstellar distances might choose a frequency tied to a universal physical constant, something any sufficiently advanced observer anywhere in the galaxy would likely recognize and understand as deliberate rather than natural background noise. This particular band of frequencies is also protected by international agreement specifically because it's considered scientifically significant, meaning ordinary terrestrial broadcasting isn't supposed to occupy it at all. The wow signal showing up almost exactly at that frequency wasn't proof of anything, but it was exactly the kind of detail that made the moment worth taking seriously, rather than dismissing outright. Researchers pointed Big Ear and other telescopes back at the same coordinates repeatedly in the years that followed, hoping to catch the signal again. It never returned. Not once. Not in decades of follow-up observation, using the same telescope, using other telescopes, at the same frequency, at the same coordinates. Ammon himself continued examining the data periodically over the following years, revisiting his own conclusions and testing alternative explanations against the record as new possibilities were suggested by other scientists, an unusually long and careful personal follow-up for a single data point. This absence matters enormously to how scientists have tried to explain what happened. A signal that repeats predictably is far easier to investigate and eventually explain. A signal that appears once, briefly, and never repeats is one of the hardest things in observational science to fully account for, because there's no way to gather more data on the exact same event, no way to run a second test, and no way to cross-reference it against a live follow-up observation the way most scientific findings eventually get confirmed or ruled out. Here's where it gets stranger. Over the decades, researchers have proposed and systematically ruled out a long list of everyday, mundane explanations. Passing satellites were considered and ruled out since no known satellite matched the position or timing, and the specific frequency band involved wouldn't typically be used by the satellite technology of that era in the first place. Reflections off space debris were proposed and tested against the data, without a convincing match to the exact signal profile recorded. In 2016, an astronomer suggested that a passing comet, or a pair of comets releasing hydrogen gas, might have produced a signal at the right frequency as they passed through the telescope's field of view. That theory generated significant attention, since comets were known to exist in roughly that area of sky around that time, and hydrogen emission from a large comet was, at least in principle, a plausible natural source at the right frequency. But subsequent researchers analyzing the same evidence pointed out problems with the comet explanation, including inconsistencies between the comet's actual documented positions and the signal's precise timing and duration, and the explanation has remained genuinely disputed rather than settled, with different specialists in the field still disagreeing in published commentary about whether it holds up under closer scrutiny. What makes the wow signal different from the broader, more general question of whether alien life exists somewhere in the universe is that this isn't a philosophical debate or a statistical argument about probability. It's one specific, documented, time-stamped event, recorded by real equipment, reviewed by a real scientist, preserved on an actual printout that still exists in the university archive and can still be examined today. The strangeness here isn't a matter of interpretation. It's a matter of a genuinely unresolved data point sitting in the historical record, methodically checked against explanation after explanation over nearly 5 decades, with no single account managing to cleanly explain every detail of what was recorded that night. Big Ear itself was eventually decommissioned in 1998, torn down to make way for a golf course expansion, a strangely mundane end for the instrument responsible for one of the most enduring open questions in the search for extraterrestrial intelligence. Newer, more sensitive instruments have scanned the same region of sky since, searching for any similar signal, coming up empty every time, which has only added to the sense that whatever produced those 72 seconds in 1977 may have been a genuinely singular, non-repeating event, rather than a signal source that simply hasn't been looked at closely enough yet. The honest scientific position today is straightforward, if unsatisfying. Nobody has definitively identified a natural terrestrial or astronomical source that fully explains the wow signal. Nobody has proven it originated from an artificial or extraterrestrial source either. It remains exactly what it was the moment Jerry Amon circled it in red pen nearly 50 years ago, a real signal, briefly and precisely detected, that matched several of the specific characteristics scientists had been watching for, and then vanished without a trace, leaving behind nothing but a printout, a single word in the margin, and a question that has outlasted the very telescope that recorded it.